So hi guys. So firstly, please let me know whether I am audible and visible or not. Okay, just confirm me once whether I am audible and visible or not. Then I'll proceed with the session. Okay, just give me a second and comment in the comment box whether I am perfectly audible and visible to you. Okay, then we'll definitely enjoy a very good and lovely session. Okay, so good evening, Anjali, Sona, Shubhankar. Okay, good evening, everyone. Good evening, yeah. Okay, so today we are here with the super 10 questions of the network theory. Okay, so my agenda behind this particular session is what in this particular session, what I am expecting. I am expecting that I'll take few questions, okay, and I'll try to take questions from all the topics of network theory. Okay, whatsoever topics we are having currently in network theory, we'll go and we'll tackle and we'll take it from each and every subject, each and every topic of network theory. That you call it as two-port network, you can call it as network theorem, you can call it as transient, AC, basic concept of network. So everything I'll be taking for you in this particular session. Okay, so you will be definitely enjoying with this particular session. Okay, agenda behind this particular session is very simple. We are here to revise complete network theory using questions. Okay, we are here to revise complete network theory using questions in YouTube. Okay, so this is our agenda behind this. Okay, so if you are thorough with complete topic, okay, if you are having command in every topic of network theory, if you want to know some special concepts, if you want to solve some beautiful concepts, I am here with you to make you do all these things. Okay, so is it clear to everyone what is our agenda behind this particular session? Okay, so you can easily see super 10 question series. Okay, for network theory, it is for all branches. All branches means what? All branches means I'll say electrical, EC, instrumentation. Electrical, EC, and what? Electrical, EC, and instrumentation. This is what we are supposed to do over here. Okay, so all the guys who are from electrical, EC, instrumentation are eligible for this particular session. That they should be having idea about this particular session, how to solve, how to approach towards the question. Okay, so just one last call for each and every one of you. Okay, tell me whether you are ready to proceed with this particular session. You are ready to proceed with this particular session. So I'll be starting with that. Okay, so please let me know once in the comment box. Yes sir, we are ready. Yes sir, we are ready to proceed with the session. Okay, then we'll go. Okay, question will be of mixed type. MSQ will be there, MCQ will be there, NET type question will be there. Okay, so everything will be there. So let's start with this particular session. Okay, so first thing that you are able to see from here. Okay, first thing that you are able to see from here is what? Ratio of time constant in build up and decay in circuit shown in the below figure is what? You can see a word build up. Build up means what? Charging. Okay, decay. Decay means what? Discharging. Decay means what? Discharging. Okay, this is the agenda. This is the agenda. Okay, so what you want to know? Time constant during charging and time constant during discharging. This is what you are supposed to do. Okay, so I'll be letting you attempt this question firstly. Okay, I'll be giving you a time of 3 minutes. Okay, to solve this. This is definitely a 2 marks question. A MCQ type question means single correct answer. Please comment your answer. Single correct answer. Okay, so please comment your answer. Please comment your answer. Okay, so I am getting the answers from you. Sona has given one answer, 3:2. Okay, others also try. Two is to three. Anjali Kumari has given answer 2:3. Okay, anyone getting the answer? Okay, so great. So let me tell you how to solve this question. First thing is that if I am saying charging, so this is a first order circuit. First order circuit. If I am saying charging, okay, see, if I am saying charging, this happens with a source. This happens with a source. Okay, discharging. This is source free. This is what? This is source free. Okay, both the things are contrary to each other. Now, when I'm saying charging, charging means what? It is going to happen with help of what? Charging means it is going to happen with the help of what? It is going to happen with the help of source. Means I'll say when switch is closed. Sorry, when switch is closed, charging will happen. Switch is open, discharging. Okay, so two time constant I would like to calculate. Two time constant I would like to calculate. Okay, so first thing is that I'll say charging. First thing is that I'll call charging. See, during charging, okay, during charging, see, the switch will be closed. During charging, the switch will be closed. So this is how your figure will look like. This is battery. L R R okay, L R R. This is 2R. This is 2R, and this is V. Okay, so what is your charging time constant? Charging time constant will be what? L by RTH, because you are having multiple resistance. You are having what? You are having multiple resistance. So you need to write what? L by RTH. And while calculating RTH, what is going to happen? It is being short circuited. It is being what? Your source is being short circuited. So your source will be short circuited means what? It will be made 0, so it will be like this, and I have to see Thevenin from here, see from here. Okay, so if we will see, this will act as what? Short circuit. So your RTH will be what? 2R plus R parallel with 0. RTH will be what? RTH will be R. RTH is going to be what? RTH is going to be R. Okay, so your charging time constant will be what? Charging time constant will be L divided by 2R. Sorry, L divided by 2R. This is your what? Build up time constant. Build up or charging. Build up time constant. Okay, next thing is what? Discharging. Next thing is what? Next thing is your discharging. This is what? Discharging. Okay, so I'll say, if this you are calling it as discharging, then in discharging what is going to happen? Your source has to be removed. So your source has to be removed. That means what? This will be, wait, your source will be removed. Switch is open basically. This is R, this is 2R. From here, this will be L by RTH. So this will be L divided by 2R plus R. So this will be what? L divided by 3R. This will be what? This will be nothing but L divided by 3R. Okay, so this is your decay. This is your decay. Okay, so basically what is my question? My question says that the ratio of time constant in build up and decay in the circuit shown below. Build up means what? Build up means you're charging. Decay means what? Discharging. So TC upon TD. This will be what? C. What is for charging? Charging is here L upon 2R. Three by 2. That means what? 3:2. So this is option number B. Option number B is what? Option number B is here 3:2. Option number B is here what? Option number B is here 3:2. Okay, getting my point? How you are getting the answer? It should be clear to you. Okay, 3:2 is your what? 3:2 is your absolutely correct answer. 3:2 is your what? Absolutely correct answer. This is your 3:2. Okay, now just coming to concept bit more. Okay, speed of system is directly proportional to time constant. Speed of system is directly proportional to what? Speed of system is directly proportional to time constant. Okay, so if your speed of system is directly proportional to time constant, so what is going to happen over here? See, initially it will charge, then it will discharge, but here charging time constant and here discharging time constant. This is your discharging time constant. Okay, charging time constant will be your what? Charging time constant will be L by 2R. L by 2R, and this is L by 3R. Okay, so what this is trying to say, that your it will charge fast but it will discharge slow. Okay, charging is fast but discharging is slow. I hope you are getting my point. Discharging is what? Discharging is nothing but slow. Okay, fine, great, superb. Okay, now I hope answer is clear, concept is clear. What is meaning of time constant, that is also clear. Pardon, it's okay, my throat is not good, okay, so that's why I'm not able to speak properly. But I hope I am clear, because with the help of mic you are very much clear, okay. So this was the question. Now coming to the next question, okay, I'm again giving you 3 minutes to solve this. I want you to attempt yourself, because then only you will get you will develop the thought process, na. Okay, so I'm giving you 3 minutes. Please solve this. Please solve this second question, okay. Please solve this second question. Okay, please comment the answer. Rathod Ajay is commenting something. I am paid batch student of electrical engineering. My thought on book, sir. I have made a short PDF, Gitopedia. Make a book of special subject and send it to a paid student. Make the book in easy and simple language and put theory into it. You convey this message to your team. See, Ajay, we are working on each and everything. Okay, I cannot commit it right now. And one more thing is that for the time being, you can focus on your class notes. Your class notes are very means that they are equivalent to a book. Everything is taught to you in very scratch. Okay, since scratch everything is taught to you. Okay, so kindly use that thing. Okay, use that book. Fine. So use that as book until and unless we come up with something. Okay, so we'll definitely try to come up with something very soon. Okay, okay, thank you. Hmm, great. See, AC came, no one commented. You know, AC circuit came and no one was there to comment the correct answer. Did you understood this question? Did you understood this question? Please let me know. Sona is saying one. Anyone else? Again, it is a MCQ, na? Means single correct answer. Single correct answer. Okay. So one answer I am getting from Sona. That is one. Okay. Anyone else who want to have a wants to make a weird guess? Okay. No, Sona, power factor of circuit is 1, but you are not asked that. Okay. You have been asked power factor of the box. See, in the circuit shown figure, if value of RMS current is 2.2 ampere. See, this is value of RMS current. That is what? That is 2.2 ampere. Okay. Power factor of the boxes. So everything will be like this. 2.2 2 ampere. So you are asked with power factor of the box. Okay, so first thing is that if you will see the resistance, what is voltage drop across resistance? Voltage drop across resistance is going to be what? 2.2 multiplied by 100. So your VR will come to be what? 220 volt. Your VR will come out to be what? Your VR will come out to be 220 volt. Okay, accidentally you see that value of V is also 220 volt. Value of V is also what? Value of V is also here 220 volt. Value of V is what? Value of V is nothing but 220 volt. Okay, that means what? VR is equal to V. What does this signify? If I'm asking you what does this particular thing signify, if VR is equal to V, then what does it means exactly? Okay, please tell me, what does this means exactly? Okay, please tell me, what does this means exactly? Resonance, exactly my point. Okay, this makes that circuit is in what? Circuit is in resonance. And one very special thing, if circuit is in resonance, okay, here omega L will be equal to 1 upon omega C. So here C will be 1 upon omega square times of L. Okay, so please pay attention. What is my C? Omega square. See, what is the answer of omega square given? Omega square is 100 pi. Okay, so it will be 100 pi square, means 100 pi multiplied by 100 pi. And what is value of L? Okay, what is value of L? Here value of L is 1 upon pi. 1 upon pi. So pi and pi gets what? Cancelled. Value of capacitance is 1 divided by 10,000 pi. 1 divided by what? 1 divided by 10,000 pi. This is your value of capacitance. This is nothing but your what? This is nothing but your value of capacitance. Fine, this is nothing but what? This is nothing but your value of capacitance. Okay, now what I have been asked, I have been asked as power factor of this circuit, power factor of the box. Power factor of box, what is there in box? Your box is connected in, your box has a R and a C. So power factor, you can say cos phi, this will be equal to R by Z. R by Z means what? R divided by under root R square 1 upon omega square C square. Okay, so this will be what? R is 100 under root 100 square will be 10,000. 1 divided by omega square. What is your omega square? Your omega square is what? 100 pi square. 100 pi square will be what? 10,000 pi square. What is value of C? Value of C is 1 upon 10,000 times of pi. Okay, wait, like this. Okay, this is the value, this is the value that you are getting. Okay, pi square divided by 10,000 pi square. Okay, so this is what you are getting. Okay, 1 upon 10,000 pi square. Okay, see, this is 1 upon omega C, na? So 1 upon omega multiplied by C. Okay, so this both will get what? This both will get cancelled out. So power factor will be equal to what? Power factor will be equal to 1 upon omega C square, na? Yeah. So just solve this. Approximately you will get it as what? Approximately you will get it as unity. Okay, power factor will be what? Power factor will be 1. Power factor will be equal to what? Power factor will be equal to 1. Because what is XC? If I'll talk about XC, XC is 1 upon omega C. Okay, so if I'll say omega, omega is 100 pi. Okay, and what is capacitance? your capacitance value is 1 upon 1000 pi. Okay, just wait. Okay, so here we have made some mistake or what? Okay, this is your 1 upon omega. What is your omega? Omega is your 100 pi. 100 pi will be this is 100 upon 10,000 and then omega square c square. So what is your omega square? Omega square will be 10,000 pi square multiplied by capacitance is what? Capacitance value is actually 1 upon 10,000. So this is 10,000 multiplied by one more 10,000 na, and then pi. So this 10,000 got cancelled, pi square and pi square got cancelled. So power factor becomes what? Power factor becomes 100 under root, this is your 20,000 na, and if I am saying 20,000, so this is what? 2 multiplied by 10,000. Okay, so this will be 1 upon root 2. So your power factor will come out to be 1 upon root 2. Okay, there was a calculation mistake that we made. Fine. So this is what? This is your 1 upon root 2. 1 upon root 2. Okay, this is 1 upon root 2. Please look at the calculation once. Please look at the calculation once. Okay, you're satisfied with the calculation? You are satisfied with the calculation? Okay. Just look at the question. Fine. Look at the calculation. Calculation is the most important thing in this particular question, right? Calculation is the most important thing. From that, power factor. Okay, this power factor is leading or lagging. Please comment everyone. This power factor is leading or lagging, and this is the power factor of what? This is the power factor of this box only. Okay. Of course, if you will talk about this particular circuit, your power factor is unity. Your power factor is what? Unity. But for this box, it is 1 upon root 2. It is 1 upon root 2. So please do one thing. What is power factor? Leading or lagging? Because inside this box, there is an involvement of capacitance. That means what? It is leading. Okay, it's not asked in question. Okay, but I am just adding something. Okay, leading. And your calculation should be very crisp over here. Okay, your calculation should be very crisp over here. Fine. Next question. Please solve this. I'm giving you 3-minute time again. You know, and focus here, and focus here. Please focus here. Please focus here. Okay. Hmm. Okay, please tell me. Comment the answer. Anyone getting the answer? Anyone able to solve this particular question? Okay, fine. You can see that this figure is perfectly symmetrical. This means circuit. If I'm talking about circuit, this circuit is perfectly symmetrical from this side. Not symmetrical from this side, but yeah, this is 2, 2, 4. Okay, this is how this circuit looks like. Current through PQ is 0. This is our first question. This is our first question. Okay, fine. So potential at S is less than that at Q. So there are many question in this particular question. Okay, so how to solve this? Fine, let's see how to solve this. Okay, this is current I1. This is 4, 2, 2, 4, and this thing. Okay, so what I can say, that whatsoever is current is flowing from 2 ohm. Wait a second. From 2 ohm. Okay, I2, same current will flow from here also, I2. Okay, same current will flow, because whatever current that will enter over here, that same current will result over here. Okay, so I2, that is what we are getting. Okay, so what you need to do, okay, what you need to do, A, B and D. Okay, so first thing is that we need to find out the value of this. Fine, so this is basically 12 volt. This is basically 0 volt. This is basically what? This is basically a 0 volt. Okay, this is what? This is like a 0 volt. Now this 12 volt has to be distributed inside. This 12 volt has to be distributed inside. Okay, so how to distribute them inside? Okay, so this is the question for us. 12 volt, 0 volt, I2 and all these things stuff. Okay, if this current is I1, this current will also be what? This current will also be I1. Okay, so current through PQ is 0. This is our first question, whether current through PQ is 0 or not. That is our first question. Okay, So you are saying this, whether your current is 0 or not. Okay, so what you can do, you can have a transformation over here. You can have a transformation of this side. Okay, so what will happen during this transformation? This is delta to star. This is what? This is nothing but transformation is what? This transformation is delta to star. Okay, if I'll be saying delta to star transformation, if I'll be saying delta to star transformation, so you need to do a transformation over there. Okay, first thing I'll be doing what? Delta to star transformation. So what will be this? This will be 4 to 6 1 7. So this will be what? 4 to 8, 8 by 7. This is your 8 by 7. This is your 2 by 7. This is your 4 by 7. This is your 4 by 7. Okay, from that what you can see, you can see that this is your 2 plus 2 by 7. This is equal to what? 14 to 16 by 7. Okay, and then this is 4 plus 4 by 7. So this is what? 20, 32 by 7. 32 by 7. Okay, 32 by 7. So that is how we are getting the number. So that is not being converted into what? That is not being converted into Wheatstone bridge. Okay, so from that particular point of view, you can solve this question, because once you will open this, okay, you will easily get all the answers, because that circuit will be particularly solved for you. Okay, that circuit will be particularly solved for you. Fine, that circuit will particularly solve for you. So just to make you clear, fine, my battery was lost. Okay, so I had to do that. Yeah, so you can easily see a very simple symmetry over here. Okay, that symmetry will result into what? That symmetry, instead of going by that, what you can say, there is a symmetry. So if you will see symmetry, okay, if you will see symmetry, where, wait, see here, it has symmetry, here it has symmetry. Okay, due to symmetry, what will happen? this current will be 0, this current will be 0. Okay, and when that current is going to be 0, what will happen? Current through PQ is 0. This is definitely a correct statement. Okay, potential at S is less than Q. Let's go into that. Okay, let's go into that. See, if this current is 0 0, what will happen? 2 2 and 2, this is what? 6. 2 2 and 2, 6. 12 by 6 means what? 2 ampere current will flow from here. 2 ampere current will flow. 2 ampere current will flow. 4 4 8 12. 1 ampere current will flow. 1 ampere current will flow. 1 ampere current will flow. Okay, so I1 is going to be what? I1 is going to be 3 ampere. Fine, so I1 is going to be 3 ampere. I2 is what? 2 ampere. That is also true. Okay, potential at S. Okay, what is potential at S? Potential at S will be 4 volt. This is with respect to ground, so this will be 4 volt. Potential at S is what? And at Q, at Q it is what? 4 and 4, 4 volt, and this is also 4 volt. So this is in total what? 8 volt. Okay, so potential at S is what? 4 volt. Potential at Q is what? 8 volt. So definitely this statement is also true. So A, B, D, A, B, C, D, everything is true. A, B, C, D is true. Okay, fine. This is also true. A, B, D, A, B, C, D, A, B, C, D. Fine. Next question. Again, this is MSQ. Okay, please look into it. Please look into it. I'm giving you 3 minutes to solve this. Please solve this. I'm giving you 3 minutes. Please solve. Anyone getting the answer? So what answer you are getting? What answer you are getting? Two ideal batteries of EMF V1 and V2 are and 3 resistance R1, R2, R3 are connected as shown in the figure. The current in the resistance R2 would be 0 if See, if you will see, I need to take a ground somewhere, na? Fine. If I'll say, what is your ground for you? What is ground for you? If I'll say this is 0 volt, this is 0 volt, okay? So this will be what? V1. This will be what? This will be your V1. I guess I am audible to everyone, na? Everyone, please let me know. Am I audible to everyone or not? Okay. See what I'm saying. Just imagine a current I over here. This is current I. Okay, and we are concerned regarding current in this R2. So this is your I1. If this is your I1, this will be your what? This will be your I minus I1, which will flow here. I minus I1. Let's apply a KVL over here. Okay, so this will be what? Minus V1 minus V1 plus I into R2 plus I1 multiplied by R1. I1 multiplied by R1 is equal to 0. See, we are focused on what? We are focused on the current at R2. We are focused on what? We are focused on current at R2. Okay, current at what? Current at R2. Current at R2 means what? We are focused on current I. Next, see a loop over here. That will be what? That will be V2 plus V2 plus I minus I1 into R3. I minus I1 into R3. I minus I1 into R3, and then minus I1 into R1. Minus I1 into R1. I want to find what? I want to find value of I. Okay, so let me expand this one. I R3 minus I1 R3 minus I1 R1 is equal to 0. So V2 plus I R3 is equal to I1 into R1 plus R3. So I1 is equal to V2 plus I R3 divided by R1 plus R3 divided by R1 plus R3. Okay, so minus V1 plus I into R2 plus V2 plus I R3 divided by R1 plus R3 multiplied by R1 is equal to 0. Okay, so like what I'll do, I'll write this as minus V1 plus I R2 plus V2 R1 upon R1 plus R3 plus I R1 R3 divided by R1 plus R3 is equal to 0. Okay, so I common, this is R2 plus R1 R3 divided by R1 plus R3, okay, will be equal to 0. This will be equal to what? V1 minus V2 R1 divided by R1 plus R3. Okay, so this will be I R1 R2 plus R2 R3 plus R1 R3 divided by R1 plus R3 is equal to what? V1 R1 plus V1 R3 minus V2 R1 divided by R1 plus R3. This will get what? This will get here cancelled, and from here you will get the value of I. Put that in option, you will get the answer for each and every question. Fine. So that is the thing. Now, in the circuit shown below, key is pressed at t equal to 0. Key is pressed at what? T equal to 0. Which of the following statement is true? Which of the following statement is true? Voltmeter displays minus 5 volt as soon as key is pressed and displays plus 5 volt after long time. Voltmeter displays 0 at t equal to L in 2 second. Current in ammeter becomes 1 upon E of initial value after 1 second. Current in ammeter becomes 0 after a long time. So this is the question. Here you can see the ammeter, and here you can see the voltmeter. Okay, so this is the question. So question is about what? Question is about C. Voltmeter displays minus 5. Voltmeter displays 0. Okay, so first thing is that question is about voltmeter reading and ammeter reading. Both this question, ammeter reading and voltmeter reading. Okay, so if the following statement is true, that is the question. Okay, so as we close the switch, okay, then what will happen? What will be the reading of voltmeter? So that is the question. Okay, try solving this one. Try to solve this one. Try to solve this one. See, after a long time, what will happen? After a long time, what is going to happen? That is the question. So when switch is closed, okay, when your switch is closed, fine. So what will be reading of voltmeter? See, let me draw a figure at t equal to 0 plus. At see, this is the figure. Now what is this? This is your 550 kilo ohm and 25 kilo ohm. 50 kilo ohm and 25 kilo ohm. This is the figure. Now we are concerned for a voltmeter reading. Now we are concerned for what? Now we are concerned for voltmeter reading. Okay, so what is going to be voltmeter reading? Okay, what is going to be voltmeter reading? Fine. So you will find what this is 5 volt. Here there won't be any voltage drop. As soon as I close this, I'll get this as what? 5 volt. Okay. So when I'll get this as 5 volt, voltmeter will display minus 5 volt as soon as key is pressed. So see, it is displaying minus 5 volt because this is 0, this is your what? So 5 volt will be displayed, and then at t equal to infinity, at t equal to infinity, it will display what? Plus 5 volt. Okay. Then voltmeter will display 0 volt. So voltmeter will display 0 volt at what? 1 upon e second. So for that you need to write transient equation. You will find that voltmeter will display what? Voltmeter will display 0 volt. Voltmeter will display what? Voltmeter will display simply here 0 volt. Fine. Current in the meter becomes 1 upon e times of initial value, means this is what? This is 36.8%. Again it is relevant to time constant, so it will be correct. Okay. And at infinity a meter current will become 0 because whole circuit will become what? Open circuit. Okay. This is very simple answer. Now, a hollow cylinder of length L has outer and inner radius of A and B respectively. If resistivity of material is rho, then find the resistance of cylinder across point M and N. First question is what about M and N? So if I am saying R, M and N, this will be rho L upon pi B square minus pi A square. So R Mn is rho L divided by pi B square upon A square. Fine. This is the first value. Try to evaluate the second value. Okay. Find the second one. Anyone getting the answer? So what will be there to find between P and Q? Okay, consider a axial ring at distance r. Consider a axial ring at distance r. Okay, here what will happen? Your r PQ will be rho dr divided by 2 pi r into L, and when I'll integrate this dr into r, okay, so it will become what? Rho upon 2 pi L ln b by a, because this integration will have limit of what? B to a. Fine, that is going to be your answer. Fine. Next thing, the switch in the below figure was closed for a long time. It is opened at t equal to 0. Current in inductor for t greater than 0 will be. Okay. The switch, circuit in the switch was closed for a long time. If I'll be saying closed for a long time, means what? At t equal to 0 minus, I am supposed to calculate the number. So at t equal to 0 minus, this should have been like this. Okay, inductor would have been short circuited. So this is 6, this is 8, this is 8, and this is your what? 32, 32. Okay, so this would have been like what? See, 32, 32 has gone. 6, 8 and 8, 4, 10. So this is what? 5 ampere. Okay, so this I0 minus is coming out to be what? I0 minus is coming out to be 5 ampere. Okay, I0 minus is coming out to be what? 5 ampere. So option number A is definitely wrong. Option number C is definitely wrong. Now what we need to calculate? We need to calculate time constant. What is time constant? Firstly, it is calculated t greater than 0, means this part is what? Disconnected. This complete part is what? Disconnected. So this will be what? If you will see, this is what? 16 parallel with 16, 32 parallel with 32, 16. Okay, and 16 with 16, 8. Okay, so L by R, 2 by 8, 1 by 4. Okay, so from that concept we will be getting option number 5 as the correct answer. Option number 5 as the what? Option number 5 as the correct answer. Option number 5 as the correct answer. Okay, this is the next question. In the circuit shown in the following figure, switch is closed for a long time, then opened at t equal to 0. The value of current just before opening the switch and just after opening the switch will be. Okay, so one, when switch is your closed. Okay, when your switch is closed, fine. See, when your switch is closed means this case. Okay, in this particular case, what is going to happen? In this particular case, your current is going to be 0. Sorry, your inductor is going to be what? Short circuited. Okay, so your figure will look like this. See, t equal to 0 minus. T is equal to 0 minus. So 20 and 10 are short circuited like this. Now this is 20, this is your 20 over here. This is your 20 ohm, this is your 20 ohm, and this is your 20 ohm. Okay, this is 20 and 20 again. This is 30 volt. We are concerned for this current I 0 minus. Okay, so this will be how much? I 0 minus will be total voltage, that is your 30. 20 and 20, 10, 10, 30. So this will come out to be what? 1 ampere. This will come out to be what? This will come out to be 1 ampere. Okay, so you can see option number A and B are wrong. Okay, now once we have opened this switch, so at t equal to 0 plus also we are concerned at 0 plus. So what will be happening? See, this is 1, this 1 will come here, and this 1 has to flow from here. Okay, so at t equal to 0 plus, what is going to happen? See, at t equal to 0 plus, this switch is open. If this switch is open, this is how your figure looks like, and here you have 1 ampere. This is 10 ohm. I0 plus, so this is what, 30 volt. This is I0 plus minus 1, so minus 30 plus I0 plus minus 1 multiplied by 20, not 20, this is 40, plus I0 plus multiplied by 10 is equal to 0. So minus 30 plus 40 I0 plus minus 40 plus 10 I0 plus is equal to 0. So this is what, 8 by 5. This is what, 7 by 6. Okay, not 8 by 5, this is 7 by 6. Sorry. This is here 7 by 6. Fine. Two-port network shown in the below figure. H21 parameter is what? H21 parameter is what we are supposed to know. What is H21 parameter? Fine. So like V1, I2, H11, I1 plus H12. So H21 is equal to what? I2 upon I1 with V2 equal to 0. Okay, so if I'll say V2 equal to 0, so this will be what? This will be short circuited. Okay, and if this is short circuited, then what is going to happen? This is I2, so this should also be what? This should also be I2, and if this is I2, this should be I1 minus I2. So just apply a KVL over here, you will get the answer in terms of I1 and I2. Okay, and the last question for the day, what is value of current I? What is value of current I? Okay, so see, it will be superposition theorem when I'll be having only voltage source. Okay, so in case of voltage source, this will be 0 due to Wheatstone bridge, but when there is current source and voltage source is not there, then we will get the actual answer. So the circuit should be like this. Hmm. 1 ohm, 1 ohm, 1 ohm, 1 ohm, and 1 ohm. Okay, so here just apply CDR to find the answer. You will get the answer, as simple as that. Simply you need to get what? Simply you need to get an your voltage division rule as your correct answer. Okay, current division rule, sorry, and you will get the answer as per this. Okay, fine. So this was your concept for today. Thank you so much and see you very soon, guys.